First, I want to thank the organizers of this special session for SETAC 2021 on science communication, uncertainties, and science advice. It's an honor to be part of this session, and I look forward to the discussion based on these slides and this talk. I want to start with the discussion of uncertainty in science. And the idea, a lot of the talks are going to talk about specific kinds of uncertainties, but I want to point out that uncertainty is an endemic and ineliminable aspect of science. Science is an inductive process. It's an amplitive process. That means that the evidence is never complete for any particular scientific claim. And it's really important to keep this in mind that there's always uncertainty in science. Now, many have viewed this as a problem to attempt to eliminate, to solve somehow the problem of induction. I prefer to look at the upside of uncertainty, to view the inductive and amplitive aspect of science as a source of its strength. This is a source of strength in the sense that because there's always uncertainty, science is never finished. It's an ongoing investigative empirical process. New methods, new evidence, and new theories can always challenge old evidence, older methods, and older theory. This is not a source of weakness in science, it's instead a source of strength in science. So the systematic requirement that you always be open to new evidence, new theories, and new methods is crucial to science's reliability. That's why science is, in general, the most reliable source of empirical knowledge we have in the world. It is because science is uncertain and thus always open to challenge. Now, this also leads to the essentiality of values in science. Values help direct the attention of scientists to particular issues and topics. This is a well-recognized role for values in science that is relatively uncontroversial, but values are also really important for assessing the acceptability of uncertainties, for accepting when you're okay with the uncertainties that are endemic in science. And this has been elaborated through the concept of inductive risk, which is always making us ask the question, is the evidence or method or theory sufficiently strong in this particular case? What are the risks of being wrong in this particular case, of accepting perhaps a new theory too soon, or rejecting potentially strong evidence or newly formed evidence as being reliable too long? What is at stake with the kind of error that we might be confronting given the uncertainty? The value judgments in these cases don't fill the gaps, but they help us assess when a risk of error is acceptable and which gaps we are willing to live with, or which gaps we're willing to step across for the time being. Values don't get stuffed into those gaps, but they help us live with and step across gaps to making claims in science. Now, this has led many, this idea that values are essential to scientific practice, to be worried about endemic biasing of science. So I want to talk a bit here about the relationship between values in science and biases in science. I think we should understand bias as a systematic deviation from the truth. This is a standard definition of bias in scientific practice, and it's one I think that helps us see the relationship between values and bias more clearly. This is partly because lots of biases in science have little to do with values. If we look back at Tversky and Kahneman's 1974 heuristics and biases in reasoning science paper, they talk about the biases, heuristics of representativeness, availability, anchoring. A lot of other social psychologists have discovered other sources of systemic bias, of sort of the mental shortcuts that we use. These are not about values. This is about how evidence gets presented to us. So one may ask, we do have biases that are not related to values. Are values themselves biasing? They can be in some cases. So values can be a source of bias when values are a reason for selecting a method to get a particular predetermined result. When you've decided ahead of time you want to get a result and you pick methods, perhaps the time frame of the study, or perhaps the model organism or the dose levels. There are ways in which we know we can bend science to get to a particular answer if you know enough about the empirical circumstances. That's where, if you want that particular answer, if you value getting that result, that's a way that values can bias science. Values can also be a source of bias for motivating an endless criticism of unwelcome evidence. If actors in science are always critiquing anything that might lead them to a particular conclusion, regardless of how strong that evidence is, that is the value, again, being a source of bias, because those actors don't want to get to a particular conclusion because of their values, because of things they want to protect, and that ends up being a source of bias. It systematically deviates you from the truth, especially when that evidence ends up being particularly reliable in the end. And then reasons for ensuring a particular outcome when that outcome is not true. So by, like, for example, ensuring that the majority of the funding that you are dispersing goes to scientists whose methodologies produce results that are in line with what you want, which is another way of bending science. So it's these sorts of examples that we see in Merchants of Doubt and Bending Science, and that create a lot of concern about the role of values in science and values as a source of bias in science. But values can also be a source of debiasing, of fighting against bias. Values can direct attention to the as yet unseen, such as with concerns about environmental justice, directing attention to fence line communities, particularly in the US, and the health impacts of those sort of air pollutant levels along fence line communities, particularly short-term air pollutant effects. Or the fact that values direct you to look in some place that needs to have empirical attention drawn to it is not a source of bias. It's a source of debiasing. It's a way to fix the historical empirical record, the scientific record, away from a biased approach. Values can also motivate different standards for proof in particular cases. Should we declare a possible harm? Should we declare a substance safe? Scientists have different senses of what counts as acceptably sufficient evidence, and that actually can motivate additional searching for new methodologies, better methodologies that actually de-bias science. So values can actually undo past biases regarding what is safe and what is dangerous. And so the question then becomes, when are values actually biasing and when are values actually not biasing or working against bias? So we can think of values and biases as an overlapping set of things, but as not coextensive. Not all sources of values in science lead to bias, and in fact can actually work against bias. So there are markers for values as potential sources of bias. If values lead to dogmatism, if someone is unwilling to be moved off of position given contrary evidence and reasons to move off the position, if regardless they just are not movable, that's a marker of a value as a bias, a source of bias. Or if someone is just unresponsive to criticism, if, for example, they're always shifting the goalposts for when they would be convinced otherwise, or they just ignore contrary evidence or new theories that might convince them otherwise. That's, again, a marker of a value acting as a bias. Or, for example, if someone has really extreme value commitment so that no other values matter, so that the amount of evidence that would convince them otherwise becomes nearly infinite, that's, again, another way of talking about dogmatism, a marker of a value as a bias. This means that value-ladenness and bias are not the same thing, that the area between that's coextensive of values and bias is an area that we can examine, and we can see markers for that particular space. Values can be a source of bias, or values can be a source of debiasing. And we need to use these kinds of markers to distinguish one from the other in practice. And what does this mean for science communication about uncertainty, which is the point of this session? What I think is really important to recognize is that values are a crucial source of trust in expertise, and thus values have to be communicated as part of expert judgment. This can be seen when we understand the nature of scientific expertise as complex, well-informed judgment. It's not algorithmic, it's not something that can be automated readily in most cases, and it is this kind of well-informed judgment to know what might be limiting, what might work, what might not, what the sort of empirical constraints are, what sort of the methodological constraints are, what the limits of one's methodology are. These kinds of expert judgments are needed throughout the conduct and assessment of scientific work. This complex judgment takes a long time to learn and to hone, and it usually is learned and honed within consort with a well-functioning community of other experts. So judgments include judgments in the face of uncertainty. And these are judgments about which questions are worth asking and judgments about when the evidence is strong enough. So this is going back to the crucial ideas of when values are essential to science. So values are essential to deciding which questions are worth asking, and values are essential to thinking about when the evidence is strong enough. So if a member of the public is trying to decide who to trust as a scientific expert or which experts to believe in, what they really need to know is, would I make the same judgments if I had the expertise? And this depends in part on there being shared values between the experts and the members of the public, that for the judgments that the expert has to make, that the public sees that they would, if they had the expertise, make similar judgments because they have shared values directing those judgments at the crucial moments of making judgment in science. So what does this mean about what to communicate? It's really important to communicate the judgments that are being made, which decisions frame and then structure the practice of the science that's being communicated, or the synthesis of the science being communicated. Why are those judgments being made? What are the crucial evidence and understanding? What are the crucial values that are doing this? And how can you communicate that the values that are being employed in these judgments are not actually biasing? How can you demonstrate that there are no markers of the values as a source of bias, to demonstrate a lack of dogmatism, a willingness to consider criticism, an openness to critique? In doing this kind of communication, I don't think experts should attempt to impart all of their expertise. That is going to be too much and overwhelming for any member of the public. Indeed, in this talk, I haven't imparted all of my expertise about this topic. I have simplified it because all the details are going to be simply too much. But non-experts, you're not trying, when you communicate as an expert, to make the non-experts you're communicating to capable of making expert judgments. The non-experts don't need to become experts in order to trust expertise. They need to see that you are a trustworthy expert, that your values judgments are not biasing, but that you're also concerned about the same kinds of things that they are. And that is how values are central to the trust needed in expert judgment. So that is my brief talk. Thank you very much for listening, and I look forward to the discussion that's going to happen on May 5th.